So students, welcome to the session. In the last session, we solved some questions based on consistency and inconsistency of a system of linear equations. We all have discussed the conditions under which a system of linear equations may be consistent or inconsistent. Consistent means when the system of equations have a solution, and inconsistent means it has no solution. So, in continuation of the same concept, let us have some more examples based on conditions of consistency as well as inconsistency. This example is what if the system of simultaneous equations this has no solution, then determine the values of A and B. Now, look at this question first. Actually, this question is completely different from all those questions which we have already solved. In the earlier questions, we were having general equations, right? And what we were doing to transform those general equations into matrix equation of the form of Ax is equals to B, right? But here in this question, the equation already given in matrix form, right? If you take this as matrix A and this as X and this as B, so what you will get? You will get it here as Ax is equals to B, right? So what is this? Actually, this system Ax is equals to B. If this system has no solution, then determine the values of A and B. Where is A? A is this element and B is this element. So you have to determine what should be the values of these two variables or numbers A and B such that the given system Ax is equals to B must have no solution, right? So before proceeding the solution of this question, you must please recall the conditions of the consistency. In conditions of the consistency, what we discuss, the system can be classified in two categories. One, Ax is equals to B, which is known as non-homogeneous system of linear equations. Second was Ax is equals to 0, which is known as homogeneous system of linear equations. But here we are having Ax is equals to B. The first thing is what? This system is non-homogeneous. This is the first point which you should keep in your mind. This system is non-homogeneous, right? Now, what are the basic conditions for the existence of the solution for the non-homogeneous system? If determinant of A is not equals to 0, then the system has a unique solution, condition 1, and condition 2, if determinant of A is equals to 0 and all dx, dy and dz are also 0, then the system has infinite many solutions. And condition 3 was if D is equals to 0, that is determinant of the matrix A, if this is equals to 0 and among dx, dy and dz, right? Among all these three determinants, if any one of them is non-zero, then the system has no solution, means inconsistent. So we will use condition 3rd here because what is given in the question, Ax is equals to B has no solution. So the given system Ax is equals to B will have no solution if the determinant of the matrix must be identically 0 and among all the three determinants, that is dx, dy and dz, any one of them must be non-zero, right? This is because this is the basic requirement or basic condition for having no solution. So let us discuss the solution. Before this, I should try to erase it. Say, the given system, we know from the conditions of consistency that the system of equations will have no solution if, see, determinant is equals to 0, D is what? D is the determinant of the matrix A, and one of dx, dy and dz is non-zero. So these two conditions must satisfy, only then the given system Ax is equals to B will have no solution. Now you can proceed. This is the matrix A, right, and its determinant is this. You can write it also like this: determinant of A is equals to D. 352 minus 281, this. Now simplify this determinant to find out its value. Its value is coming out to be 0, right? Should I calculate it? See, determinant of D should be 0. So this is the determinant and this is equals to 0. The value of the determinant is coming out to be this. See, 3, delete the row and column in which 3 lies. What you will get here? Minus 8a minus 9, right? Then minus 2 minus minus, you will get here plus 2. Delete the row this and this in which 2 lies. 5 into a is 5a, minus 9 into 2 is 18, so 5a minus 18 plus 1. Delete the row and column in which 1 lies, so it lies in the first row and third column. 5 into 1 is 5, minus plus 8 into 2 16, minus 16 means this is plus, and this is given equals to 0 because the condition is what? The determinant of the matrix A must equals to 0. Now if you simplify it all, what you will get? This is what? Minus 24a, 8 3 are the minus 24a, 9 into 3 minus 27, the first bracket is this, 2 into 5a, that is 10a minus 36, 15 plus 6 is 27 plus 27. Now minus 24a and plus 10a, you will get minus 14a. Clear? This is a very simple calculation. Minus 27 minus 36 plus 21, you will get it as 42. So from here, minus 14a minus 42, this is equals to 0. So minus 14a will be equals to 42. So a is equals to 42 upon 14, and this is minus 14. This is a is equals to minus 3. So the value of a is coming out to be minus 3. So condition 1 is there, the determinant of the matrix D must be 0, and the second condition is what? Any one of the 3 determinants dx, dy, dz must be 0. Now write down dx. You know how we should write down dx? Dx can be written as simply replacing the first column of the determinant D by the entries at the right hand side, that is this one, B3 minus 1. First column should be replaced by the column of the right hand side in the given equation, that is this one. So B3 minus 1 and second and third column, they will remain as it is. And what we need to show, any one of dx, dy and dz must equals to non-zero. So dx is this matrix, right? Dx should not equals to 0, and simplify this. See, what is this here? B. Delete the row and column in which B lies, right? This. What you will get here? 8 into minus 3, 24 minus 9, right? Second is what? Minus 2. So minus minus plus 2 is here. Delete the row, this, and column in which 2 lies. 3 into minus 3 minus 9, 1 into 9 is plus 9. So this is minus 9 plus 9. Plus third term is 1. So 1, and then delete the row and column in which 1 lies. 3 into 1 is 3, minus 8 and minus 1, you will get minus 8. So 3 minus 8. And simplify this, what you will get here? This B 24 minus 9, you will get 24 minus 9, you will get 15b, right? So 15b minus 9 plus 9 will be cancels out. What is left here? This will cancel out. 8 minus 5 minus 5, this must be equals to non-zero. So 15b must not equals to 5 and b must not equals to 1 upon 3, right? So what we conclude from here, if a is equals to minus 3 and b is not equals to 1 upon 3, then this system Ax is equals to b will be inconsistent, means it will have no solution, right? This is actually a different kind of question rather than what we did in the last few cases, right? Let us take this example as this is a word problem. Actually, I have taken this problem because you must understand how the concept of the determinant or the Cramer's rule can be used in practical areas or in practical fields. So the question says what? An examiner is preparing a question paper containing 9 questions, is worth of 3, 4 and 5 marks based on difficulty, right? He wants number of 4 marks questions to be 1 more than the number of 3 marks questions, and the total worth of the question paper is 35 marks. Determine how many 3, 4 and 5 marks questions could be there. So what is the objective? The objective is this: a paper is given to a teacher or an examiner. He has to set 9 questions, right? Total number of questions in the question paper are 9. Among all those 9 questions, there are the variety of questions. Few questions are of 3 marks, right? Few are 4 marks and 5 marks, right? So out of total questions are 9. In 9 questions, some are of 3 marks, some are of 4 marks, and the remaining are of 5 marks. 3 categories of the questions, right? So the first thing is what? The examiner is preparing 3 kinds of questions. 1, 3 marks, 2, 4 marks, 3, 5 marks. What you want to determine? Determine how many 3, 4, 5 marks questions could be there in the question paper, right? So you have to determine how many questions of 3 marks, how many questions of 4 marks, and how many questions of 5 marks should be there in the question paper. So what we can do? We can assume let x be the number of questions of 3 marks, y be the number of questions of 4 marks, and z is the number of questions of 5 marks respectively. Clear? X number of questions which contains 3 marks. There are y number of questions which contains 4 marks. There are z number of questions which contains 5 marks. This is what we assumed, right? See, total number of questions in the question paper are 9. This is given to us. So total means x plus y plus z is equals to 9. This is our equation number 1. Clear? Because the question paper contains the 3 varieties of the questions: 1, 3 marks, 2, 4 marks, and 3, 5 marks. So we have assumed there are x questions which are of 3 marks, there are y questions which are of 4 marks, and there are z questions which are of 5 marks. So x plus y plus z must be equals to 9. This is our equation number 1. What is given as the next condition? He wants number of 4 marks questions to be 1 more than number of 3 marks questions, right? Number of 4 marks question means this is y, and number of 3 marks question means this is x. He wants 4 marks questions 1 more than number of 3 marks. So y represents the number of questions which contain 4 marks, x represents the number of questions which contains 4 marks. So 4 marks question to be 1 more means y is equals to x plus 1. Number of questions which contains 4 marks, they are 1 more than number of questions which contains 3 marks. So x represents the number of questions which contains 3 marks, y represents the number of questions which contains 4 marks. So y is equals to x plus 1. This is equation number 2. and what is third thing is given, and the total worth of question paper is of 35 marks, right? So if x represents the question of 3 marks, so we will get here 3x plus 4y plus 5z, this is equals to 35, right? So these are the three questions. Now this question number 3 can be written as minus x plus y, this is equals to 1. So this is equation number 1, this is equation number 2, and this is equation number 3. So this is how we can transform a word problem to the mathematical equations, right? And once the equations are obtained, then we can very easily use the method to find out its solution. Let see x, y, z denote the number of 3, 4, 5 marks questions respectively. Then x plus y plus z is equals to 9, because total number of questions in the question paper is 9. And what is the total worth of the questions? What means how many marks should be given to the total question paper? That is 3x plus 4y plus 5z is equals to 35. And second is what? 4 marks question to be one more than the number of 3 marks question. From here y is equals to x plus 1. So we will get third equation as minus x plus y is equals to 1, right? See, this is what? This is again a system of linear equations. Now we will solve it by Cramer's rule. So first transform the system of linear equations to the matrix equation Ax is equals to b. So as usual, the above system of equations can be written in matrix form as follows: Ax is equal to b, and you know what is A? A is simply the matrix of the coefficients of the variables x, y, z involved in the equations, right? So, and capital X represents the 3 variables x, y, z, and b simply represents the constant terms at the right hand side, that is 9, 35 and 1. Clear? Now how you can write down the matrix A, you all know, because I have explained this process many times. A simply refers the coefficients of the matrix, sorry, coefficients of the variables x, y, z in 3 equations. So coefficient of x, y, z in first equation is 1, 1, 1. So first row is 1, 1, 1, right? Take the second equation. Coefficient of x is 3, coefficient of y is 4, and coefficient of z is 5. So what we will get? 3, 4, 5, 3, 4, 5, right? And third is coefficient of x here is minus 1, coefficient of y is 1, and coefficient of z is 0, because we can write it like this: minus x plus y into plus 0 into z, this is equals to 1, right? So this coefficient is minus 1, here coefficient of y is 1 and coefficient of z is 0. So minus 1, 1 and 0 is your third row. This is the matrix, and capital X and capital B are also specified. Now start your process. The first step is what? Find out the determinant of the matrix this, so its value is coming out to be this, right? Simplify this, you will get its value as minus 3, right? See, I have explained how we can expand this determinant along any row or any column. Say this 1, 4 into 0 minus 5, take the second, let us do me fast. Second is minus 1, this row 3 into 0 is 0, 5 into minus 1 is 5, this is 1 minus 5, and third is, the last is 1, so delete the row this and this column. 3 into 1 is 3, 4 into 1 is minus 4, so 3 plus 4 is 7. So simplify this: minus 5, this is minus 10, 3 plus 4 is 7, minus 10 plus 7, you will get minus 3. So determinant of the system Ax is equals to b is non-zero, and it simply shows that it will have a unique solution, right? Because if the determinant is not equals to 0, then the system has unique solution. Now what we will do next? We will calculate dx, right? Dx, dy and dz, right? And you know how we calculate dx? dx is simply calculated by replacing column 1. See here, replacing column 1 by the terms at the right hand side of the given equation 9, 3, 5 are by this matrix this. See here, you can use any one of them. Dx, I have explained this process many times. Dx is simply obtained by replacing the first column of the determinant by 9, 35 and 1. Similarly, dy can be simply obtained by replacing the second column of the determinant by 9, 35 and 1. Similarly, dx can be obtained by simply replacing the third column of the determinant A by 9, 35 and 1. So, first, second and third columns are respectively replaced by the matrix B, that is 9, 3, 5 in the given determinant to find out the values of dx, dy and dz. Let us have on the next slide. This is your dx. The first column is being replaced by C 9, 35 and 1. This is the replacement. dy, the second column is being replaced by 9, 35 and 1. The remaining two columns in dx, dy, dz will remain the same. We are not going to change them anything. So, first column is this. In dy, the second column is replaced by 9, 35 and b 1, and in dz, see, the third column is being replaced by 9, 35 and 1. This is how we can find out dx, dy and dz by simply replacing first, second and third column of the determinant by the matrix B, that is 9, 35 and 1. Now, you can find out the value of each determinant. I think, should I explain the process of finding out the determinants? Take 1, dx, 9, delete the row and column. What is left? 4 into 0, 0, 5 minus 1, you will get here minus 5, right? What is the second term? Let me explain one. The remaining two you can do yourself. Second is minus 1, right? What is here? Delete the row and column in which 1 lies. So, this row and this column. What is left? 35 into 0 is 0. 5 into 1 is minus 5. So, this is minus 5. Third is plus. Plus minus plus, right? 1. Delete the row and column in which 1 lies. So, 1 lies in the first row and third column. What is left? 35 into 1, 35. 4 minus 1 is 4. So, 1, 35 minus 4. Now, what is left? 9 into minus 5 is minus 4, 5. Minus 5 into 5 plus 5 plus 35 minus 4, that is 31. So, this is equals to what? 31 plus 5, 36 and 45 minus 45 plus 36, you will get here as 9. Right? This is the value of dx. Now, similarly or on the same pattern, you can calculate the values of dy. So, dy is coming out to be C. What about dy? This. The first element is 1. See this and this. 35 into 0, 5 minus 1. So, this is again minus 5. Second element is minus 9, right? See. Minus 9 means delete the row and column, this row and this column. 3 into 0 is 0, 5 into 1 is minus 5. Minus is also there, so this is 5. Plus third element is 1. So, see, the last is 1. Delete the row 1 and this in which 1 lies. 3 into 1 is 3 and 35 into 1 is minus 35. So, minus plus, you will get this. Simplify this, you will get here what? 1 into minus 5 is minus 5, 9 into 5 is minus 45, plus 35 into 3 is 38. Simplified, it is coming out to be minus 12, right? Likewise, you can calculate dz. So, let me explain this also. What is left? dz for third one. The first element here is 1, right? So, delete the row, this and this. 4 into 1 minus 35, that is 4 minus 35. Second element is minus 1, right? So, minus 1 is with what? delete the row and column. 3 into 1 is 3, minus 35 means 3 plus 35, minus minus plus. Third element is plus 9. See what happens with 9. Delete the row and column in which 9 lies. So, this and this, 3 plus 4, that is, this is 9 and 3 plus 4. What you will get? 4 minus 35, this is equals to minus 31, minus 35 plus 3, that is 38, plus 4 plus 3, 7, 7, 9, the 63. Simplify it, you will get it as minus 6. Now, we can calculate the values of x, y and z. You know, x is equals to dx upon d, that is minus 9, and the value of d is minus 3. So, x is coming out to be 3. Similarly, y is equals to dy upon d. So, y is coming out to be 4, and similarly z is equals to coming out to be 2. So, z is equals to 2. So, what we conclude, x is 2, y is 4 and z is 2 is the required solution of the given problem. What does it mean? If you look at the problem, there were total number of questions were x plus y plus z, they were 9. And what we assume, x number of those questions which contains 3 marks, y number of those questions which contains 4 marks, z number of those questions which contains 5 marks. So, what we conclude, substitute these values, 3 plus 4 plus 2, this is equals to 9. Satisfies. So, our solution is accurate or correct. What it concludes actually, in the question paper prepared by an examiner, there should be 3 questions which are of 3 marks. There should be 4 questions which are of 4 marks, and there should be 2 questions which are of 2 marks. So, this is how actually this example also shows how we can use the theory of matrix, theory of determinants, the Cramer's rule, to find out the word problems which we generally facing in our day-to-day life, right? So, students, I think I should stop it here, and I will continue the remaining exercise based on the same principle or same method in the next slide. Thank you very much.